Hello there. Today we are going to see something about hill climbing. Let me make it about a big screen, and then let me take out a pointer, pen, and then let me go with the same color. Okay. Hill climbing problem in AI. Today we are going to see something about hill climbing problem in AI. Before I start the video, I request you to please subscribe my channel. Now the first part, simple hill climbing, whatever it is a hill climbing problem. We call it as a simple hill climbing. It is a local search. It got information about the local only. We call it as a local search, and it is a greedy approach. Greedy approach means it will get you the best solution. If there is no bet, if we got the best solution, it will stop there, it will not go forward. So if I've got 1 2 3, after some time if I get a 7, but if you think that 3 is the best solution, it will give me 3, it will not go move forward. We call it as a greedy approach. Once you get a best solution, you will stop, you will not go forward, and there is no backtracking. So what do you mean by backtracking? I'm going to 1 2 3 4, again I count back to 3, I cannot go back to 4. It will not take backtrack. It will tell you the best solution. If there is no best solution, it will stop. It is a greedy approach, and it got all the information of local search. Evaluate. Let's take example. You are just climbing on a hill. This is my hill, and then you're climbing like this. Do remember, you're climbing like this. Evaluate the initial stage. Loop until solution is found. If no option available, stop. If there is select, evaluate the new stage. If goal, then quiet. If better than the current stage, then the new stage. Right? You are moving here. This is the better state. Yes, this is my current state. If I move here, this is my best state. Before that, this was my best state. This one is my current state. It will go up this one. If you are climbing blindfoldedly and you go up on the top, you say, this is my best solution. This is my best solution. Or you can call it that we call it as max value. Okay, we will be seeing all the algorithm, we will be seeing a problem, and we will solve this problem. So just keep in mind, we'll come back again and we'll see all those things. A local, it give you what is climbing, hill climbing. It give you the local information. It is a greedy approach. There is no backtracking, and if you find the best solution, it will stop, and if there is no goal, it is quiet. It will initiate the initial value. If you are in a hill climbing, and if you're climbing, you always go up. If you're going backtracking, means what? If you're coming back, means you're getting negative values or low value than the high value. So we call this one as a top value, or we call it as a max value. Now what are the problems in hill climbing? Now if you are going on a blindfolded, you've been blinded and you want to go up. Now this is my x-axis and this is my y-axis, which is x, and this is y. If you are going up, let's take, you are going up, you are going up, you are going up, you are going up, and your steps are at the standstill position. You think this is my maximum position. When you remove the blindfold and you see there is one more high peak available, that should be your max, correct? But you cannot go down. This is not a backtracking. So it will give you the information of local maxima. It will not work. It's already got a maximum value. It will not go back. So the first problem it will give you is local maxima problem, and if you want to go again, you have to come backtrack, and you have to start again. This we call it as global maxima. It all depends upon your heuristic values. Whatever the heuristic, if the heuristic value is 3 and if heuristic value is 5, this is your local maximum, this is your global maximum, and it is already achieved a local variable. So local maximum is already been achieved. So remember, do one thing. When we are climbing blindfolded on a mountain, and when we just going up like this, so our legs are going up at one small position and one position, our legs are standing at the same place, we think this is our maximum position. But when we remove our blindfolded, we will see another height here. We call this as a local maximum. This is called a maximum. I just given the heuristic value based on that one. And this is the problem of hill climbing. The next problem, there is one more. With the help of this, we can able to solve the problem also. Now I have got a box here, which has got 1, 2, 3, 4, and this is space. This is my result 1. Okay. Now let's take an example. What are the mismatches? 1 is correct, 2 is not, 4 is not, because it is in the middle. I can move on 4 position, red, right, left, down, up. Correct. It can move all this one. Let's move on. I have moved on my right position, and I've got 1 which is place. 2 is not there, 3 is not there, this is no 4 is not there. It is not match, it is matches. This is not match, this is matches, this is matches, and this is not matches. So how many matches? 1, 2, 3, 4, 5. This should be 5. My heuristic value is 5. Now let's move on to left. Move on this one. So 1 matches, yes. 2 doesn't matches, this doesn't matches. I'm matching with this one. Do remember, I'm matching with this one. 5 doesn't matches, 7 doesn't matches, 8 not matches, 3 matches, 6 matches, 8 doesn't matches. So how many? 1, 2, 3, 4, 5, 6. I've got 6 values. Here same way, here also I've got D, which is matches with 7. And here also I've got 7. Which is the minimum I've got? I have to go with this one. I have to go with this one. Correct. Now this can move up, and this can, for if I go down, this is here means it can go 3 position. It can go up, it can go down, and it can go left. It cannot go right as it is blocked. So if I go to the left, what is the value I've got? If I've got up, I've already gone up. So 1, 2, 4, 2, 4, 1 comes down, 1 comes down, 5, 7, 3, 4, 8. 1, 4 doesn't matches, 4 doesn't matches, 1 doesn't matches with the 1. If we go for doesn't matches, 5 matches, 7 doesn't matches, 3 matches, 6 matches, and then this is what? 8. 8 doesn't matches. So what? 1, 2, 3, 4 matches. What is this? 1 is not matching. Sorry. 2, 3, 4, 5, 6. Again, H is equal to 6. What? I'm getting heuristic value more. So I have to. If I getting more, means I have to stop. This is my best. We have to get minimum heuristic value. Minimum heuristic value I'm getting means this is my best position. This is my best position. Look at it here. If I'm going up, again I cannot go up. This is my best position. This example, and then we will also solve one more problem. We have got other problem with this one is plateaus or flat maxima problem. What do you mean by flat maxima problem? You are climbing on a hilltop. Like this, like this, like this, like this, like then there is a straight path will come to you with all licks one. Let's take example. This is 1, 2, 3, 4, and this become 5, 5, 5, 5, 5, 5. Then this is 6. So all the value when you're calculating the problems, you are getting all the 5 values. So all the neighbor value are same. So we call this as a flat or plateau's maximum value where there is no change. But you'll get a other heuristic function later on, but after 3-4 stages you are getting only 5. Other one is rigid. What do you mean by rigid? Let's take an example. On a blindfolded, I have moved on. There are x, y axis. This is x-axis, and I'm going to on z-axis. Look, I'm going on like this, and I come to this maximum place. Fine, but I'm on this way, and I open my blindfolded. I see there is a what do you call? There is a one more peak B which is on the next direction, but I cannot change the direction. That's why I'm going on an x and y axis, and if you see a heuristic value more or a peak on a next direction, that I cannot change it. So it will stop at it cannot change the direction. It cannot change the direction. This is what a rigid problem. Rigid problem is something like that. We are going on an x and y. We find a more heuristic value on z means it cannot change. Plateaus means we are getting a same value, heuristic value for few times, like 5, 5, 5. And the other one is that once you find a local maximum, you cannot go to global maxima. There are three problems. Hill climbing is something like that. It's just a greedy approach. It will move steady at some point and it will find the best solution for you. And if you find there is one more best solution, it will not tell you up. And there is no backtracking. Now let's solve a problem. Now let's solve a problem on hill climbing for a local maxima and global maxima. I've got a disk which are placed B, C, D, A, and this is my goal. I have to get it. There are a few points which I have to remember. If the number doesn't match, it is -1. If the disk doesn't match, it is -1. If they match, +1. Means if A is there, after that B comes, it is +1. If A is there, after that C is there, they're not matching, it's give you -D. So I have got one. This is my one problem. This is one. So what? B. Yes, B, first A should be there, B is there, -1. After B, C is there, +1. After C, D is there, +1. After D, -1. So this is what? -1, -2, +0. I have got it, correct? First, and that one is +4. First, calculate the heuristic value based on matching number. So did we calculate it? It is 0 and this is 4. So given heuristic value is 0 and goal heuristic value is 4. So first what we have calculated? We have calculated the heuristic value. The next one, sorry. Next, what we have the step? I have got this disk, correct? Sorry. This step, I have got this one, A, B, A, D, C, B. Here also, A, D, C, B. I go back to bring my A here. So A is a correct position, +1. B is not in a correct position, -1. And C is on a correct position, +1. D is also after C, D will come, +1. So what is my goal state? It is like this: A, B, C and D, correct? This is my goal. A is in the right place, B is not in the right place, C and C. So -1, this is +1. Sorry, this is -1, +1, +1, +1. So what? -1 +3, it will get you +2. Is it not? My heuristic value is 2. After 0, I got 2. Is it greater? So I can move forward based on my heuristic values. Now two possibilities are there. I can bring my D here or I can go by my option here. So B, C, B and C, -1, +1, D, D, +1, -1. So what will be? It is 0. If I bring it here also, it is 0. So now what I have to struck at here, if you see it, I have struck at this one, 0, 0. I've got it. Here also, I've got these values, correct? I've got the local maxima here. Then afterwards, I got this problem, 0, 0. The same way here also, I've got it. 0, 0. Now both the values, if I go position, I am getting 0. So now we will go to other position. What is that? We will see about global heuristic. What do you mean by global heuristic? There is some rules. +1 for each block placed in proper place. Minus for each block placed in improper place. We will see with the help of an example. Okay. Now before B there is nothing, 0. After B we have come C. C is not in proper place, -1. After C, D comes, correct? No, it is 2 blocks are not, -2. After D, A comes, so -3. So -3, -2, -1, that is -6. Before 0 there is nothing. Before A nothing, 0. After A, B block come, this is +1. After B, C is coming, there are 2 blocks, +2. After C, 2 blocks are coming, +D. This is +6, correct? So in the step, given the heuristic value -6 and goal heuristic value is 6, we have calculated our steps. Here what we are doing, we are going for global heuristics. Now step 2, I bring this one to A2 here. What happened? Before B there is nothing, 0. After B, C, -1 minus D. So this becomes what? This becomes what? Minus 3 with respect to goal. This before A there is nothing. So 0 with respect to goal minus 3. Is it good? Yes, because before that we got minus 6 with respect to goal. Now we have got plus 3. We have increased. Now step 3. What I have done it? I brought A down. We have brought D. I have brought D here. So what happened? Minus 0 plus this become minus 1. This is also minus 1 because this A comes here, this D also. Before D there is nothing. 0 before A is 0, before B 0, after that minus 1. So this becomes minus 1. So with respect to minus 6, minus 1 is good. We are moving up. Then we go to step 4. What is step 4? B, C, D, A. Minus 1 before B 0, before A 0, before D 0, before C 0. We have got 0. Correct? We got a very good step which is going to come down here. Next comes step 5. What is that? 0. I place this B on A. So after A plus 1. Correct? Plus 1 comes. D and C leave out. Then step 6. After A, what is that? This should be, what is my goal solution? A, B, C, D. A, B. This is B. Correct? This is B and this is C. I am just placing this C here. Whatever the C is there, I am placing this is become plus 1 plus 2. Minus plus 1 plus 2 because A is there. After A 0 plus B will come plus 1. Thus become this is plus 3. Yes. Then after that one A, B, C, D. Plus 1 plus 2 plus 3. That is plus 6. Did we not got the hero? What we have seen it here. This is we have seen about global heuristic. What about here? We have seen it about local maximum. This we stop because we both are getting 0, 0 values. This is local maximum. So in hill climbing problem, we have seen two things. Let me go back again and tell you up. We have got local problem, then plateaus, then rigid, then we solve a problem on this. Thank you very much. Do subscribe my channel. Thank you.